Okay, let us start our discussion on uh, derivative again. I want to say is that we should start from the basic. As we suppose you are going to moving in a car, we traveled 1 hour, and after that we traveled a distance of 60 kilometer. Then, if I someone asks what is the speed as the 60 kilometer, if tells you, but what happened actually at 10:30 a.m. If I ask, this is what derivative at that instant. The speedometer does not look at the whole journey. It, to what that speedometer will going to be, it will take a tiny interval around 10:30, from 10:30 to 0.001 second, and what is the distance traveled in that time, and divides it. That ratio is called instantaneous speed. The mathematically you can say that if you want to find out the derivative at that particular point, what is that f of x 0 plus h, a minute distance in the um, what is the change in the input, um, the output, what is the answer. But thing is, not to say function is differentiable, it means we have to check at the same case of in case of curve also. I think if you want to calculate that, you should take two adjacent points to that, then only you can what is the change in the input and what is the change in the output. The left side and right side should be equal. But what happens? It should be a continuous. Then only you can say that the function is differentiable. It must be a continuous. Because of the continuity, as change in the x as h tends to zero, because of the what happens because of the continuity, the limit of, I can say that f of x as x tends to for example, I want to say whatever the y value delta y, that is called delta f of x 0 plus h minus f of x 0 must also tends to 0, because what happens in this, I will tell you, suppose limit of f of x as x tends to x 0 is equal to f of x 0. Is it correct? It means that initially it x 0 and y 0 means that is f of x 0. It means that limit of f of x as x tends to x 0 becomes f of x 0, means y going to become y 0 tending to y 0. Therefore you can say that as x tends to x 0, the whatever the y value is there, no, you can say that whatever the y means f of x, this x plus h, you can say that they becomes tending to x 0. That is the reason you can say that um, this is very important, as it is a continuous, the you can say that. But the one question comes in our mind, if suppose if you take circle, what happens in this state? What for differentiable, what happens, you take neighborhood of that point on the same branch. What happens if suppose circle is there, you take a on the branch, you can so choose a point x1 and y1. There are for if you minute change in the x1, you can get two values, maybe upper branch and lower branch. And what we consider only that adjacent point consider. If you consider far away point, the ratio becomes infinite, because what happens in case of circle or parabola, you can say that y square is equal to 4x, like that. If you other than the curse origin, if you point choose any on the lower branch, or lower branch, if you select x0 and y0, some minute change in the x0, there are two values, I can say that. But which ratio you consider? But thing is, if you consider far away point, that become whatever the delta y by delta x tends to become infinite. Only we consider adjacent points around that on the same branch. We can very important. Then only you can say that the at that point you can say that the function is differentiable. Because other point if we consider, that becomes infinite. And one more thing, we consider the only the adjacent point to left side and right side, that those points should be satisfy the equation of the curve. The branches, they should, the both the point nearby points are, they must pass through the I can say that that branch. This is what I want to say is that, okay, their points stay in the same smooth arc, and that is what the implicit. This is what we can understand here. If you move along tiny and the edge, we can go nearby the points on the same branch or jump to opposite. if you consider the adjacent point, if you and if you consider, okay, if you we only consider the adjacent point, but what happens if you consider the far away point? The ratio becomes infinite. The jump to the opposite branch gives a huge delta y. That is, h is tiny. The delta y will delta h tends to infinity. Therefore, you can say that we want to consider a if you want to find out the derivative at that point, we should choose a neighborhood point around that point. Okay, on the same branch, we can say that. Therefore, we can say why the car analogy, because you want to calculate at that particular point what is the minute change distance covered by that distance. In the same fashion, in similar fashion, if you want to calculate that derivative at that particular point, we need to choose adjacent point. Based on that, what is the ratio? Why suppose x0 y0, to take a point on, and what is the left side and x1 y1 and right side x2 y2. Whatever, if you calculate y2 minus y0 divided by x2 minus x0 in the right side, it should be equal to the left side, that is y1 minus y0 divided by x1 minus x0. But in case of probability in circle, or in case of two points, you may ask that per unit change in the input there are two outputs. But why we consider only on the same branch? If you consider other branch, that is not the derivative. It gives somewhat infinity and it will not give you. Only on the neighborhood point we can consider. This is how we can say that. Okay. Okay, let us start what happens actually at the cusp point. For example, at the cusp point, we can say that at least one of the suppose what happens if the point is suppose f of x y is equal to 0. If you want to find out derivative at that point, at least one of the partial derivative should be non-zero. Then the point is regular, smooth. If it is, then this is the unique point. Divide, you work out the dy by dx, and if of xy is equal to 0, then you can get this formula. I will tell you how this formula is arrived, all those things. Let us, for a while you can understand. Dy by dx is equal to partial derivative of f with respect to x divided by partial derivative of f with respect to y with minus sign. If suppose it is, if it is unique at that point, the only possibility that it should, one of these non-zero. Both are zero means what? There is a only one possibility to because as I told you, at the cusp or the node, we can get two slopes. Maybe the cusp, I think the two slopes are equal. Repeated slopes are, you can get it, but they are, in order to get, they are going to represent for different branches. In order to say that the one can get the node also can get two different slopes. In order to I can say that represent that, the only possibility is that if it is get 0 by 0 from that region only, three things are happening. If it is, then this, if suppose I can say that it is cusp or a singular point. One is the point will going to satisfy the equation and you can get 0 by 0 form, and I can say that the partial derivative of x with respect to partial derivative of y, they are equal to 0. This is why they are, you can say that if it is unique, there is only possibility that non-zero. One of the possibility partial derivative is non-zero. It is not, since it is not unique, we can say that it gives 0 by 0 form. That is one thing. And you may, one question comes in case of cusp, whenever if you work out the, I can say that both are 0, the derivative for both are 0 by 0 form, means the dy by dx is going to approaching 0 on 0 for, but both the branches approaches 0. But what is the direction? I can say that direction is different. One is approaching 0 from the positive side and one is approaching from the negative side. Therefore, they are not approaching from the same side direction. Therefore, you can say that still it is not a smooth point. Even though they can approach the same point, you can say that um, the reason it is a pinch. Okay, that is what you can say that. Um, at node, you can say that you can get again to what happens if you here. What a very important thing at the cusp, what happens if you want to find out the I can say derivative at 0 comma 0, what you can do, the, as I told you, two things are possible. You have to choose first very adjacent point to the 0 comma 0. That should, okay, whenever two adjacent point chooses, the left side will going to left side point will going to, I can say that they will satisfy the one function, and right side point will going to satisfy the others function. Therefore we are going to get a different slope. Definitely we can say that they are very close to the zero, but what are somewhat they minus point zero zero something and positive plus point zero zero something, we can get it. They may tend to zero zero. That's the reason only you can get two slopes. You can get whenever you solve quadratic, you make the quadratic and divide by x, you can get two repeated slope. I will tell you further how can you get it. That reason only, in order to represent that minus point zero zero something and point plus point zero zero something, the only option for divide by x is 0 by 0 form, because it is not exactly equal to 0. The left side will going to become 0 point plus 0.00 something, left right side minus 0.00 something. In order to represent that, the only option for divide by x is only 0 by 0 form. Otherwise if it is 0, I can say that one of the we can say that if the partial derivative of y is 0, then you can say that directly it is uh, not exactly equal to 0, you can say that. But the thing is what happening here, the approaching 0 from like this, therefore the only possibility is that dy by dx is equal to 0 by 0 form in that case. And in case of node also, what happening, whenever if you choose a, adjacent points and the left side and right side, they becomes, I can say that, for example, if this is the classical example, we can get two straight lines. Means whenever there is a node here, what happens this case, in case of suppose x cross like this, there is a x like representation is there. At the node we get two adjacent point will going to lie on the one branches, and other two pair of adjacent points will going to lie on the other pair. It means two different slopes at a point, you can see. But in case of what happens, normal smooth curve, only you can get the, for one branch you can get one slope and other branch also. Which one is take? Therefore there are two different slopes. That reason only, again in this case also, dy by dx is equal to 0 by 0 form. And isolated point, there is no nearby points on the curve at all. There is nothing to take a limit over that. Net derivative is meaning less here. Totally we can say that regular smooth curve, okay, well and good. They limiting process, the nearby point exist. The both the both partial derivatives are not zero here. You can get unique tangent in cusp, but derivative exists, one common tangent exists, but both branches, they becomes like, as I told you, 0.00 something, and one other one is minus 0.00 something. What we can say that they are still, in order to represent that dy by dx is equal to, we cannot say that it is only option for that it is 0, dy by dx is equal to 0 by 0 node can take two distinct tangents, you can get it. Therefore it is a similar point. This is how we can understand. Now the question comes, okay, coming to the proof of this chain rule, for if you're going to use here, let us z is a function of x and y, and x and y are functions of t, but keep in mind they are continuous functions, because we not to find out dz by dt. uh, you can say that z is a function of x and y, and x and y are the functions of t here. Okay, in order to prove that dz by dt is equal to, that is df by dx divided dx into dt, df by plus df by dy into dy by dt, we have to prove that. Then by the basic definition of dz by dt, in order to change in the z, what happens, z is a function of t, then you can say delta z is equal to the f of x plus of t plus delta t, y of t plus delta t minus like this, f of x t and y of t. This is what represented by divided by delta t, and delta tends to 0. Delta x and delta y, we can say that this is what delta x is equal to f x of t plus delta t minus you can say like this. Now the numerator is called, you can say that x plus delta x y plus delta y, x plus delta x. Okay, uh, I can say that we can say that x is equal to x of t here. If delta t tends to 0, you can get f of x. That is what add. And now what we can do, we can rewrite this one as the numerator can rewrite like this, because we know that delta x is equal to like this. Change in the delta x is represented by x of t plus delta t minus x of t. The change in the delta y is represented by like this. And we can delta z, you can represent the add and subtracting. You can say that x plus x comma y plus delta y in the numerator, we can get like this. And delta z by delta t, you can, after this one you can rewrite like this. Nothing we have done here. And what we can say, this part, we can say that this part can be written like this. Left side, this part, if you where you have to divide and multiply the by the, what we can say that delta x we have written here. That's we taken this part and divide and multiply this one. Can finally this becomes this part becomes, I can say that x comma, and similarly this part you can write like this. And taking delta t tends to 0, as we know that they are, because the z is a function of x and y are the continuous function. Delta t tends to 0, delta x and delta y tends to 0, because as I told you, as if the function is continuous, if you make a change in the input, the output also decreases. Means since you since if the function is continuous, if you decrease the input, the change in the input means if the change if you I can say that the change in the input decreases, the change in the output also decreases. I can say that that reason only, if they continuous, that reason only you can say like this. And first term you can rewrite this one as what we can rewrite, that is df by dx. Okay, the change in the mm, with respect to only the, we have not changed the keeping y constant, you have only changed the x here. That is called df by dx and dx by dt. And the second term we can rewrite, that is df by dy. Finally we can arrive this result, beautiful result we can get. Only thing is, we have to understand the function is continuous. What the z is a function of x and y. In order to difference x and y are the functions of t, the z should be, the x and y are the continuous functions. Keep in mind. Uh, okay, that region only, as I told you, this is what we can understand here. Now, with that basic formula chain rule, we have to prove that what we can prove dy by dx is equal to minus partial derivative of f with respect to x divided by partial derivative of f. We can do it. Just take it. We have, suppose the function is there, z is equal to f, f of x y, and I can say that where x is, z is a function of x and y, and x and y are the functions of t. You can take it. But here what happens, this fxy is equal to 0 here. In this case, the dz by dt here, what happens if it is 0? What happens, we already proved that z is equal to f of xy, and we have proved already dz by dt is equal to df by dx and dx by dt, and again plus df by, if the function is given f of xy is equal to 0, then what happens, what you can say that dz by dt is equal to 0. Then after that, what happens in this case, it becomes 0, df by dx is equal to like this, and df by dy into dy by dt is equal to like this, and finally you can get the final result. That's all. Because you can get dy by dx is equal to, if they given f of xy, z is equal to f of xy, if they given, we arrive this result. If z is equal to f of xy, you can get result, this result. Same thing here, what happens, they given f of xy is equal to 0, then definitely you can get like this. This is how we can do it. Okay, the simple thing we can arrive it. Based on this, if dy by dx at that particular point, if it is 0 by 0 form, means partial derivative of f means what? Keep differentiating the f with respect to x, keeping the y constant. That is called partial derivative of f with respect. If it is then partial derivative of y with respect f with respect to y is 0, means there is not unique. You can get slip is unique. It may be a cusp or node, or I can say that isolated point. But how to find out? This doesn't mean that derivative does not. You can only say that it is not unique. Still, we can say that find out the dy by dx. See here, dy by dx is equal to 0 by 0 form means it doesn't mean that there is no value for dy by dx. May exist, but it is not unique. Keep in mind. Only thing, it is not unique. But how to find out that? That in order to find out that, make it in quadratic. The dy by dx, it make it quadratic. Then you can find out the dy by dx. Then the question comes, how to make it quadratic. Okay, now exactly what the I can say that we want to make it the quadratic. Suppose we actually let us the curve is given by f of x y is equal to 0. We arrive. We already know that f of x is equal to 1. You can get a regular point. You can get unique slope, unique slope. But if both f of x derivative of x f with respect to x and derivative of f with respect to y they are 0, you can get singular point. You can say that. Okay, already know these things. And you want to make it, but is undetermined means I can say that it doesn't mean that slope exists, but only can say that it is not unique slope. There may be a two slopes or maybe a repeated slopes, as you told in case of cusp. But how to find out that? You have to make it the quadratic in dy by dx. In that, to find out that, again you differentiate the f of xy with respect first time, and again we have to differentiate this equation with respect again with respect to x. Since whatever we can get it, the f of x is the, I can say that, uh, f of x is the, what happens, it is a function of, again see, is a function of x and y, because y is a constant here. F of fy is the partial derivative of f with respect to y is also function of x and y. Therefore, we can apply the chain rule here. But use a product tool here. This is what the differentiation of using a product tool and chain rule on each term, because the d by dx of f of x first. How to apply this? Again, by applying the chain rule, we are going to this d by dx of fx, you can get this result you can get it. And the product tool, the d by dx of this one, we're going to by product tool, as I told you, sorry, by product tool and chain rule, we can obtain this rule. Okay, finally we can get these things, and ultimately we can get the quadratic in this equation. And based on this quadratic, see here, we can get this result, no? But we already know that this becomes 0, because fy is equal to 0, and this finally the result, we can get the quadratic in equation like this. And what we can get if discriminant, we know that how to classify the point. Suppose x square am square plus bm plus c is equal to 0, and here by quadratic equation you can say that a is equal to f partial derivative of y with respect to y, and again with respect to second, that is called a, and b is um, like this, and c is whatever this is like this, and discriminant you can get it. The discriminant is b square minus a square, like this. If d is greater than get 0, you can say that two distinct real roots, and d is equal to 0, that is called, it is a node here. And similarly, d is equal to 0, it means repeated roots are exist. The one tangent with multiplicity of 2, because two branches, I can say that they are going to, that is cusp point. As I told you, both are tending to 0 from the positive side and negative side. Both the branches touch the x-axis, turn back sharply, and d is less than 0, we can get isolated point. This is how we can understand the things. If d is greater than 0, that is called node. Two distinct nodes can exist, that is called crosses itself, because I can say that this is only possibility that two distinct means it is a node and it is d is equal to 0, it is cusp, one repeated touches then turn back sharply, and this is how we can understand the things. Okay, this is how totally we can say that how to ultimately arrive the result, how to find out the quadratic and all those things. Thank you.